Today, we're going to continue talking about integration by parts. We need to get a few more examples in because at this point we have a total of 1, which is not quite enough. Remember that integration by parts is the anti-product rule, where integration by substitution was the anti-chain rule. The good news is integration by parts has a formula that we have to remember. The bad news is, of course, that integration by parts has a formula that we have to remember. But it's based on the product rule. We're just turning around the product rule and picking one to be the thing that we're integrating. So the parts formula says the integral of u dv is uv minus the integral of v du. The steps for integration by parts are as follows. Step 0, make sure that this is not substitution. We would rather do substitution when that's available. So first, make sure that substitution is not going to work. Then we can actually start the parts process. We have to decide on what's u and what's dv. This is where we have to make a choice. Our choice should be guided by what dv is. dv needs to be something we can integrate. That's the only rule that we need. dv must be something we can integrate. We already have to know the antiderivative of whatever we call dv. There are ways you can decide. There are mnemonics that you can use. The best thing to do is to remember that dv is something you know how to integrate. Step 3 or step 2, find the other parts. Get the found parts. So step 3, 2, counting is, I started my counting at 0, which is throwing me off. So step 2, find du and v. So differentiate to find u, find du, integrate to find v. Differentiate u to find du, integrate dv to find v. That's why we need dv to be something we can integrate. Step 3, put your 4 parts, or actually there's only 3 parts in the formula. dv doesn't show up again. Put the 3 parts into the parts formula. Now notice that the parts formula has another integral. We're integrating u dv and another integral shows up on the other side. So that's the next step. Step 4, integrate what we've been calling the secondary integral. Step 4, integrate the secondary integral. And then finally, repeat as necessary. Sometimes the secondary integral is also a parts integral. So the secondary integral might be a parts integral. So those are the steps that we need to take to do integration by parts. The big thing comes down to deciding on u and dv, but we'll try to simplify that as much as possible by just saying that dv must be something we know how to integrate. So let's take a look at some classic examples. Yesterday we did an x times the sine of x. Today I want to look at, say, x cubed times natural log of x. Classic integration by parts example. Step 0, we want to make sure that this is not some substitution problem that we can do. And we don't see anything, we got an x cubed, but we don't see an x squared, and the x cubed is not part of a composition. There's also not something in the natural log where we can assign something to be the inside function. So step 0, this does not look like a substitution problem. We don't have anything that we could substitute. So step 1, we need to decide on u and dv. Yesterday, we just kept putting the polynomial in u and the other stuff in dv. We did one whole example. If we tried that, if we said let u be x cubed and dv is natural log of x, this assignment of parts is not going to work. We don't know the antiderivative of natural log of x. We know the derivative of natural log of x. We don't know the antiderivative of natural log of x. So this is a miss. So here we don't know the antiderivative of natural log of x. So natural log of x cannot go in the dv slot. We do know the derivative of natural log of x. So let's try switching them up. So let's say u is natural log of x, and let's set dv to be the x cubed. You haven't attempted a parts on a parts problem if you haven't attempted it twice. So step 1 complete. We have decided what's u and what's dv, and guiding that decision was dv had to be something we can integrate. Step 2, differentiate u to find du. So du, the derivative of natural log of x is 1 over x dx. And integrate dv to find v. So v is 1/4 x to the 4th. Now we have all four parts. We only need 3 of them, but now we have all 4 parts. We are ready to plug into the parts formula. So the parts formula says the integral of u dv is uv minus the integral of v times du. So uv is going to be a 1/4 x to the 4th times the natural log of x minus the integral of v times du. So 1/4 x to the 4th times 1 over x dx. That's step 3. Put the parts into the formula. Next, we're going to have to evaluate this secondary integral. So I'm going to simplify it. I've got an x to the fourth times 1 over x. And so I can cancel out one factor of x. So here we're going to have 1/4 x to the fourth times the natural log of x minus, I'm going to factor out a 1/4. I like my constants in front of my integrals. X to the fourth times 1 over x is x cubed dx. So I'm going to simplify my secondary integral before I integrate it. Now I'm ready for step 4, integrate the secondary integral. So you have a 1/4 x to the fourth times the natural log of x minus 1/4 of 1/4 x to the fourth, so 1/16 x to the fourth. And since we're done with our integration, we can put a plus c. So eventually we'll gain experience and we'll have an idea about what goes in the dv, what we can integrate. For now, the most important thing is the most important thing to do is something. So when we're learning process things like this, and back in the before times when I would have office hours, when students came to office hours and they said, I don't know how to do problem 5, my first question was always, show me what you did. And if the answer was, I didn't know how to start, then I usually said, go have a seat at that table out there and do something. Then we'll have something to work with. Go make a mistake so that we have something to correct. Here's a cool thing that we learned about this particular problem. We integrated this natural log of x by differentiating the natural log of x. It turned natural log of x into 1 over x, and then it canceled out one of the x's, and I was just left with a polynomial. And that was a really cool thing on the part of natural log of x. It went from this weirdo natural log function to a nice rational function, 1 over x. So if that x cubed wasn't there, we can find ourselves in this scenario. Let's suppose I just wanted to know the integral of natural log of x dx. This was the thing that we didn't know in the previous example, and why this couldn't serve as the dv. So following the previous example, I'm going to make the natural log the u part, and then dv is just everything else, which is just 1 times dx. Sometimes the strategy in parts is to integrate by differentiating, and that means the dv is just 1 times dx. That's step 1. Step 2, differentiate u to find du. Integrate v to find dv to find v. Then we can put things together in the parts formula. The integral of u dv is uv, so I'll have x natural log of x minus the integral of v times du, x times 1 over x dx. Step 3, put everything into the parts formula. Step 4 would be to integrate our secondary integral. I'm going to simplify x times 1 over x and write that as just 1. Now I can integrate my secondary integral, and the integral of natural log of x is x ln x minus x, and since we're done with the integration, plus c. Two wins here. We got to do another example. We integrated something by differentiating it, and now we know the antiderivative of natural log of x. The integral of natural log of x is x ln x minus x. Knowing stuff is great, but just like in Call of Cthulhu, knowing stuff can also have terrible consequences. In the previous problem, we made our lives easier when we did not know the antiderivative of natural log of x. So we just had to move the natural log of x over to the u slot and differentiate it, and we got that nice, easy, clean integral. But now we know the natural log of x, so you could probably see where this is going. Everybody make a sanity check, because we're going to do a problem again. And we're going to observe, now we know the antiderivative of natural log of x. So that's awesome, but that's also terrifying because we know stuff. And so that previous thing we said before, when we didn't know the antiderivative of natural log of x, we know that now. So what happens if u is x cubed and I put in the dv slots the natural log of x dx? Earlier, we said we don't know antiderivative of natural log of x, so we can't use this. But now we can. So we can do this now. And then you're all like, oh, but do we gotta? And Mike all, no, no, no. Yes. Because we have to know if this is going to work or not. I shouldn't be able to just switch these where I now know the integral of natural log of x and have it not work out. If it doesn't work out, then there's something seriously wrong with our process. Let's find out. Du is 3x squared to x, and v, a little messy, but we know it. The integral of natural log of x is x ln x minus x. We've got our parts, so the next thing is to plug them into the parts formula. The integral of x cubed natural log of x to x is uv, so x cubed times x ln x minus x minus the integral of v times du. So v is x ln x minus x times du, which is 3x squared dx. All right, this looks worse, but we know that there's an answer here. So let's press on. Let's see where this is headed. So I'm going to distribute the x cubed. So I have x to the fourth natural log of x minus another x to the fourth. Okay, so that's no problem. I've got this factor of 3. I want to factor that 3 out, and I'm going to distribute an x squared. So that's going to be minus 3x cubed natural log of x minus x cubed dx. I'm going to emphasize that there are 2 terms in my integral, even though the integral and the dx form a grouping symbol. Now here is where an interesting thing happens. Is interesting the right word? I don't know. Here's where an interesting thing happens. The reason that I do this problem in reverse. Notice that our secondary integral, one of the terms is x cubed natural log of x. That's our original integral. Our secondary integral, a copy of our original integral, has shown up in our secondary integral. A copy, actually -3 copies of our original integral, is in our secondary integral. So I'm not going to bother integrating that again because that's the integral that I'm working on. I'm just going to take those 3 copies of x cubed natural log of x, and I'm going to add it to both sides of the equation. So notice that our original integral has this x cubed ln x. So I'm going to rewrite this side of the equation. So I've got my integral of x cubed natural log of x dx. I have this x to the fourth natural log of x minus another x to the fourth. I have -3 times the integral of x cubed natural log of x dx. And -3 times a minus is +3 times the integral of x cubed dx. So those are the 2 terms of my secondary integral. And what we're going to do is add 3 copies of the integral of x cubed natural log of x dx to both sides of this equation. So I'm going to add 3 of these integrals to both sides of the equation. And that means over on the left, I now have just 4 copies of the original the integral that I'm looking for. I still have an x to the fourth natural log of x minus an x to the fourth. This has been moved to the other side, and the last integral is the secondary is now just a +3 integrals of x cubed dx. Now I just need to do my secondary integral. Now, this does not look the same as what we had before. There's an x to the fourth natural log of x, but it's just no 1/4. The 1/4 happens here when I divide both sides by 1/4. Also notice that I have negative 4/4 x to the fourth plus 3/4. So this is going to be negative 1/4 x to the fourth. So what we have is 4 copies of the integral of x cubed natural log of x dx is x to the fourth natural log of x minus 1/4 x to the fourth plus c. But that's for 4 copies of x cubed natural log of x. If I just want 1 copy, I divide everything by 4. So the integral of x cubed natural log of x is 1/4 x to the fourth natural log of x minus 1/16 x to the fourth plus c. Which is what we had before. So this raises the question, why would you do it this way if the other way is easier? And the point is not coming up with 1/4 x to the fourth natural log of x minus 1/16 x to the fourth plus c. The point is that we couldn't put natural log of x in the dv slot because we didn't know the antiderivative of natural log of x. Once we learned the antiderivative of natural log of x, we had to make sure that that would fit with our parts formula, because now we could be out in the wild integrating stuff and say, well, we do know the antiderivative of natural log of x, so maybe that's how we proceed. This could happen to you, so we should test it to see that it is okay. This also resulted in something very important that happens. When we were doing our secondary integral, a copy of the original showed up. And so we learned a new technique, a new strategy, for a new thing that might happen. If we get a copy of the original integral, we should gather that onto with the original integral, get multiple copies of that original. And then everything worked out. The other reason it doesn't make any sense to say, why would you do this when the other way is faster? Because what's even faster still is to recognize that we know that the integral of x cubed natural log of x is 1/4 x to the fourth natural log of x minus 1/16 x to the fourth plus c. Why would we write anything down? We already know what the answer is. Always be suspicious of someone making an argument, especially in a math class. Well, let's just skip, let's not know this because some other way is faster. Faster isn't the point. Because there are faster ways still. Wolfram Alpha could do this a lot faster than this whole thing. Doing something faster in your math class is not the point. Knowing what can be done and why it works, that's the point. Coming up with the answer, that's just an artifact. The reason that your teachers want you to come up with answers in the same form is that if everybody does the right thing and comes up with the same answer, it makes it really fast for me to grade things. That's why your teachers want you to answer in very specific ways. So they could take a stack of 60 papers with 4 answers on it and knock it out in a half an hour and just grade it in a half an hour. Because if I ask you what the integral of x cubed natural log of x is, and I can see this at the end of your work with a big old box around it, I only glance at the rest of it to see that it came out right. Incidentally, if you're thinking you could just look up on Wolfram Alpha what the answer is and then fake the stuff in the middle, it is super obvious when you're faking it in the middle. Because I pick up one thing that's contradictory that does not connect the beginning to the end in what you're proposing as your work. One thing, and it's all wrong. And it's like, oh, look, you're lying to me, -4. That's not 0 out of 4, that's -4 out of 4. That's such an egregious error, I make it cancel out one of your previously correct answers. I'm just kidding. It's -8 out of 4. I cancel out 2 answers for being so insulting. I'm just kidding. I shadow ban you from the class. I'm just kidding. I would never drop a student and then let them know, tell them I dropped them. I get them kicked out of the school. I'm just kidding. That's going way too far. Any questions?
Hey, Professor, could you move the paper up a little bit so I can see the whole thing? Thank you. Oh, okay. So I'm a little bit confused as to like the final answer and how you got them.
Uh-huh.
It just doesn't really piece together with me. Like how did you get from like x cubed to like x to the power of 4, natural log of x minus x to the power of 4 and stuff like that?
Where?
In a final answer, like right below the boxes. Or
from
like,
where do you not get where this came from? What is it about this?
where it says equals x to the power of 4, natural log of
Yeah.
x minus x to the power of 4.
Yeah, what is it about that? What's the previous line above say? The line above that, the line above that? Where does it go wrong?
Oh, I was wondering what happened to like the x cubed times like x natural log of x minus x.
X cubed times natural log where?
Where it's orange,
up here?
orange and purple. Yeah.
Here?
Yeah.
Okay, so
or right below that.
Right below that. So here's the integral of u times dv. And so I have u and v. So u is x cubed. And when we integrate natural log, we get x ln x minus x. So that's the v. So here is u times v minus the integral of v times du. So the v is x ln x minus x, that's here. And the du is 3x squared dx. So here's the 3x squared dx. So here, at this point, we have just plugged everything into the parts formula. That's step 3. Then what we did was a little bit of algebra. So notice that here, I've got x squared, and I can multiply it by the x ln x, and I'll multiply the x squared by an x. That gives me an x cubed natural log of x, and x squared times x is x cubed. So that's where those two came from. And then
that makes more sense now.
The 3 is just a constant multiple, and it's because these terms are in parentheses, it's multiplying all this stuff. So I just factored the 3 out. Then after I factored the 3 out, I'm like, oh, well, shoot, I actually wanted the 3 back in there. And this is just me having the habit of factoring my constant multiples out. But then this 3, this is where I said, oh, shoot, I actually kind of want this 3 back in there. So I split up into 2 terms. This term, x cubed natural log of x, and this term, x cubed. And I had to distribute the -3 to get this integral. And I distribute the -3 to the second term to get that integral. So that's where those parts came from. This is where we made the big, where we noticed the big thing. Our secondary integral had a copy of the original integral, x cubed natural log of x, and it was multiplied by -3. So I add 3 of these things to both sides. So I'm just adding 3 copies of the integral to both sides to cancel it out on the right and put 4 of them on the left. So this is just adding up 1 of those integrals plus 3 of those integrals is 4 of those integrals. And then it disappeared from the right side.
Right. But I'm also kind of unsure. How come we started integrating like the x cubed ln or natural log of x dx plus 3 and x cubed?
What do you mean?
So like on top, like on the line above that, you're only integrating x cubed and natural log of x. So how come we started integrating the x cubed at the end?
Down here?
Right above it.
Up here?
Yeah, that one.
So this integral applies to both of these terms. It's the integral of this term and this term dx.
Oh, I didn't see the parentheses.
Here,
Okay.
the integral starts here and the dx ends what we're integrating. So there's 2 terms in there, x cubed natural log of x and x cubed. So those are those 2 terms down here. Here's that first term and there's the second term. Those are the 2 terms in our integral. But since the x cubed natural log of x was just the original integral, I moved that one, those 3 to the other side to get 4 of my originals. And all I had to integrate was the x cubed as my secondary. It only seems like it's a lot to remember because it's a lot to remember and you have to remember all of it all the time in perfect detail. So if you're like looking at this problem and saying, dude, this is like confusing, that is correct. That is the correct response. This is the 4th example that we've done for integration by parts. So if you're a little confused right now, that is the correct answer. If you're not confused at all, then there's probably something wrong with you. And I think that's weird. If you're like, oh, nope, parts is super easy. Totally got it. Then I'm not worried about that. But if you're like, oh, dude, this is kind of weird, then yeah, that is correct. The reason that you know this is going to be weird and you don't like it is you're like, oh, dude, when am I ever going to have to do this? To which I respond in my usual way, dude, don't call me dude. And second of all, you're probably not. Just, full disclosure. If you're in your job as an engineer and you're about to integrate something by hand and you're not just tutoring the boss's kid, you're probably about to get fired. Because your boss is going to be like, oh, are you seriously doing integration by hand? And you'll be like, oh, yeah, I'm trying to utilize the skills that I learned in college. If your boss is a reasonable person, he'll say, college is not for learning skills. It's for gaining education. But if he's just a regular boss, you're like, oh, okay, pack up your desk. Any questions? All right. That's going to be it for today. Note that this week is a short week, so there's no class tomorrow because there's a big holiday of some stripe on Thursday. And it's not just like a typical day off type of holiday. It's one where families feel compelled they have to get all together. So that means Wednesday is kind of useless. Like even in normal circumstances, when there's classes in person on Wednesday, no one friggin' shows up because everybody has stuff to do. In particular, they're going to be going shopping. And if you're going to go shopping on Wednesday, first of all, if you fail to plan, then you plan to fail, and it's just going to be bad. Because everybody's going to be doing their last minute shopping. Everybody's going to be stressed out. It means that they're going to be acting like assholes. So, I mean, take care of it sooner rather than later. Today is probably actually even too late. Anyway, point is, I'm not running classes tomorrow. I'll be available via email if you have questions. I'm behind on my emails, but I'm trying to get caught up. So hopefully I'll get caught up soon. Anyway, that means no class tomorrow. I will see you all on Monday. Everybody have a good long weekend. And thanks for playing.